Here is a question about equilibrium of charge, and we will solve this by using Coulomb's law. A charge Q is placed at the center of line joining two equal charges Q. So there are two equal charges. One is plus Q, another one is also plus Q. The small charge Q is placed at the center of line joining. So this is a line joining between these two charges. And the small charge Q is placed at the center. If I say R is a distance between these two charges, this is a center, then this is R by 2 and this is also R by 2. Equal charges Q. The system of these three charges will be in equilibrium if Q is equal to. So they told the whole system of these three charges is in equilibrium if the charge Q is equal to. So we have to write this small charge Q in terms of this capital Q. That is what this problem about. Now we will have to use the Coulomb's law to calculate what is a small charge Q in terms of capital Q. And they told that these three charges which are kept in a line in equilibrium. Equilibrium means on each charge the total force is equal to 0. That means on this charge, for example, if I take this plus Q charge, on this charge the force of repulsion between these two and these two is 0. That is, the force acting on this charge because of this charge plus force acting on the same charge because of this charge is equal to 0. This is a case of equilibrium. Now, how much is the electrostatic force of repulsion between these two charges? That is 1 by 4 pi epsilon naught. Product of charges is Q into small q by distance between them is R by 2 whole square plus the force of repulsion between these two charges is given by 1 by 4 pi epsilon naught. The product of charges is Q into Q by the distance between them is R square is equal to 0. This is a case of equilibrium. Now we will just have to solve this. So I can take the whole thing that side. So I lose my 1 by 4 pi epsilon naught. So you're left with Q into Q by this is R square by 2 square, that is 4, can be multiplied here, is equal to, this is minus 1 by 4 pi epsilon naught anyway cancelled. So this is Q square by R square. So R square get cancelled here again, and I can write this small q, that is what I want. So Q is equal to minus Q cancel, 1 Q remains, dividing by 4. So this is, so if the charge which is at the middle is this charge by 4, the magnitude is 1/4 of this charge, then the whole system will be in equilibrium. So that's all about this problem.